So I think I have solved. Yeah, only one problem, right? How many problems we have solved in the last class?
One, sir.
One, sir.
Only one. Only one problem, right? Okay. Today we shall solve one more problem. Then we'll move further with the resistance and the reactance of the transformer. Okay. Take down this problem. A single phase 400 volts 50 hertz transformer is built from stampings having a relative permeability of 1000. So he has given V. Then he has given permeability, relative permeability 1000. The length of the flux path, LG he has given. The length of the flux path, right? See here. He has given the length of the flux path is 2.5 meter. What is this length of the flux path? LG, right? He has given the length of the flux path 2.5 meter. The area of cross section of the core is 2.5 into 10 raised to minus 3 meter square. What is this area of cross section? It's a gross AGI, right? He has given the area of cross section of the core is 2.5 into 10 raised to minus 3 meter square. And the primary winding has 800 turns. TP he has given. Calculate the maximum flux and no load current of the transformer. You need to calculate phi m and I naught. The iron loss at the working flux density is 2.6 watts per kg. He has given, right? What he has given, the iron loss at the working flux density is 2.6 watts per kg. Okay, and once and he has given the weight of the iron. Iron weighs 5.8 into 10 to 3 kg per meter cube, and he has given the stacking factor as 0.9. Okay, these are the data he has given. Now you have to write down the data given. First, write down what are the data. Okay, so let us write down the data given. Okay. Okay. What are the first thing? P is 400 volts, and relative permeability you can take mu r as 1000. Then the length of the flux path LG is given 2.5 meter. Then what else he has given? AGI, gross core area, 2.5 into 10 raised to minus 3 meter square. Okay. Then TP, number of turns on the primary, 800. Okay. And you need to calculate what? You have to calculate what is phi m and what is I naught. What else he has given? The iron loss. Iron loss, that is Pi, he has given as 2.6 watt per kg. Okay, and iron weighs how much? 5.8 into 10 raised to 3 kg per meter cube. And stacking factor SF is given 0.9. Okay, these are the datas as given. Let us start finding the unknown quantities. Okay. So, are you able to see? Are you able to see?
Yes, sir.
Yes, sir. Yes, sir.
Right. Okay. So, you have to calculate.
Yes, sir.
Okay. You have to calculate phi m, right? So, how do you calculate phi m? In which quantity this phi m is imbibed? If you remember, phi m is equal to Bm into Ai, isn't it? How do you calculate phi m? Maximum flux is equal to flux density into area, iron area, right? And how do you calculate Ai?
SF into AGI.
Yes, correct. That is 0.9 into
2.5
AGI.
into 10 to the power minus 3.
Okay.
It is
That
given.
is,
It is given, sir, AGI.
AGI is given. From that you can calculate what is the AI. Okay. Once you calculate AI, you can calculate BM. How do you calculate BM? You know, that is E is equal to 4.44 F BM into AI into TP. This is the EMF equation, isn't it? So from this you can calculate what is BM. You know E, so you know F also, you know AI also, you know TP also. So you can calculate what is BM. Once you calculate BM, substitute the value of BM here. And you know AI. So you can easily find out what is phi m. Okay. This is the calculation of maximum flux in the core. Next, what he has asked you to calculate what is no load current. So you know the no load current is given by under root Im square plus Ic square, right? So I am okay. So Im, how do you calculate Im magnetizing current? If you want to calculate the magnetizing current, then you must calculate MMF.
AT naught.
Exactly. AT naught divided by root 2 TP. Right? If you do this, you will get Im. So how do you calculate AT naught first? You need to calculate AT naught, no? So how do you calculate AT naught? This is reluctance multiplied by flux. This is your MMF, magnetizing MMF. Reluctance multiplied by flux. Then how do you calculate reluctance? That is inverse of permeance is a reluctance, isn't it? Or inverse of reluctance is a permeance. What is that given by? L divided by mu AI, isn't it? Length, if you remember, it is length divided by mu into AI, area, into maximum flux. Okay, and what is this? mu naught, mu is equal to mu naught into mu r. Mu r is given. Mu naught, you know. What is the value of mu naught? What is the value of mu naught? 4 pi
4 into
ah,
10 raised to minus 7.
exactly, right. 4 pi into 10 raised to minus 7 is your mu naught. So substitute all these value. Li and he has given Li, right? So once you substitute, you will get the values of 80 naught. Once you get the value of 80 naught, you can easily find out what is Im. Okay. Now, how to calculate IC? Okay. So, if you want to calculate IC, you must know what is the volume of the core, because it is the loss component, right? So, if you want to know the loss component that is happening in the core, then you must know what is the weight of the core. To know that, you must calculate what is the volume of the core. Okay, volume of, how to calculate volume of core? Volume of core he has given 2.25. If you remember, just go back, you'll find out that is 2. The area of cross section is given, right? That is not 2.25, it is 2.5 area of cross section, isn't it? So area of cross section into length of the flux path. So he has given length into area, you will get the volume. Just, are you able to understand? How do you calculate the volume? Area 2.5. 2.5, na? What he has given? Area how much?
2.5.
Huh?
2.5 into 10 raised to minus 3.
Yeah. So that is what he has given. 2.5 into 10 raised to 3. 10 raised to minus 3. Into,
Yes, sir.
Into 2.5. That you will get a volume. Okay. Into 10 raised to minus 3 into 2.5 meters. So what you will get a volume of the core. Okay. Once you get the volume of the core, then find out what is the weight of the core. Weight of the core. So weight of the core, he has the data what he has given is what is that he has given 7. What is that he has given?
Weight of iron, sir.
Yes, he has given, no? Okay. So weight of the iron 5.8, na? How much? 5.8 into 10
Yes, sir.
raised to
5.8 into 10 raised to 3.
So you have to see weight of the core is volume of the core multiplied by weight of the iron, right? So you will get the weight of the core. Once you get the weight of the core, then you can easily find out what is the iron loss. So iron loss is equal to, he has given, see here, how much it is? The iron loss at the working flux density is 2.6 watt per kg. So you have to multiply this 2.6 into weight of the core. What you will get is iron loss. Once you get the iron loss, then you can easily calculate what is IC. IC is equal to iron loss divided by V. Huh? So this is how you can calculate. Once you get IC, you have already calculated IM, then find out what is I naught. Are you able to understand how to calculate? Huh? Can you calculate this now? Can you calculate this?
Yes, sir.
Okay. Do one by one. First, calculate what is AI.
So 2.25 into 10 raised to minus 3 meter square.
2.25
Into 10
into
raised to minus 3
10 to minus 3.
meter square.
Okay. Okay. That's fine. So net core area, net core area you have found. Now calculate what is BM.
Sir, it is 1, sir.
So one,
One,
sir.
1 Weber per meter square.
1.00, sir.
Okay, ठीक है. So now you have to calculate what is 80 naught. So what is 80 naught now? What is 80 naught? Li is how much? 2.5 meters. Mu AI you have calculated. Phi mu no. So first you have to calculate phi m, no? What is the phi m now? What is the value of phi m?
2.25 into 10 raised to minus 3, sir.
Phi m?
Ha, sir. Sir,
How is
BM
it
is
what?
Yes, sir.
Huh?
Because flux density will get equal to 1, sir. So phi m will
Correct.
be 2.25 into 10 to the power minus 3.
Correct. So it is also 2.25 into 10 raised to minus 3 Webers because BM is 1. Fine. Right. So what is 80 naught? Total ampere tons? Calculating?
1800.
1800. Check out.
So 2000.
2000. 2.5 divided by 1000 into 4 pi into 10 raised to minus 7 into, see, Li is how much? 2.5.
5, sir.
2.5, sir.
Mu naught is 4 pi into 10 raised to 7 into 1000.
Nu r is 1000.
So AI is how much?
2.25 into 10 to the power minus 3.
Into 5m.
Sir, into 5m.
Into 5m.
Yes, sir. 5m is 2.25 into 10 to the power minus 3.
Yeah. 2.25 into 10 raised to minus 3. So this will cancel, na? So finally 2.5 divided by 4 pi into 10 raised to minus 3 into 1000. How much you will get?
Sir, 1989.43.
Sir, 1990, sir.
198.
1989, sir. 89.43.
43, sir.
Okay. This is ampere turns. 1989. All of you got the same value or what? 2.5 divided by 4 pi into 10 raised to minus 3 into 1000.
So 10 raised to minus 7. So 4 pi into 10 to the power minus 7. Mu naught value, sir.
Huh?
Mu naught value, sir.
7.
10 to the power minus 7, sir.
Yes, correct. I have written here, no? 4 pi into 10 raised to minus 7.
Yes.
4
Yes.
pi, So, all of you got this value? 1989.4. Anybody has got the different answer?
So I am getting 2000, sir.
Huh? You are
2000.
getting 2.5 divided by, I am also getting 1989. 2.5 divided by 4 pi into 1000. So it is nothing but 4 pi into 10 raised to minus 3 only. Isn't it? So let us take this value. I have also got the same value. 1989.4 amperes. Now calculate volume of the core. So volume of the core is 2.25. I should not take 2.5. Why I am taking 2.5? Because it is the value of AI. You have got 2.5 na? Area of the core, net core area, AI. How much you have got? 2.25 into 10 raised to minus 3, right?
Yes, sir.
Yes, sir. 2.25.
So volume of the core has to be, net core area into length. So that is 2.25 into 10 raised to minus 3 into 2.5. How much you got this?
5.625.
5 into 10 raised to minus 3.
6.25 into 10 power minus 3, sir.
Yaudri?
Sir,
2.5,
5.625.
2.25
Sir,
into
5.625.
ಚಿನ್ನ 6 ಹೆಂಗ್ ಬರ್ತದ 2.25 into 2.5 ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರ್ತದೆ 6 ಹೆಂಗ್ ಬರ್ತದೆ
5.625 into 10 raised to minus 3, sir.
5.625 into 10 raised to minus 3. This is what you will get. 5.625 into 10 raised to minus 3. This is the volume of the core. Now calculate what is the weight of the core. Volume of the core into weight of the iron. So how much you will get? Weight of the core?
32.625 kg, sir.
32.625 kg, sir.
30?
32.625
kg. Isn't it? So volume of the core is 5.625 into 10 raised to minus 3 into weight of the iron. What is the weight of the iron? 5.8 into 10 raised to 3, isn't it? So 32.625 kg is the weight of the core. Now calculate iron loss. Multiply 2.6. Okay.
84.825, sir. 84.825, sir.
84.825 watts. 84.825 watts. Now calculate what is the loss component of the current. 84.825 divided by 400.
0.212, sir.
0.212.
0.212.
0.212 amps. Now calculate I naught.
So 49.73, sir.
Im square plus IC square under root. How much it is?
49.73 whole square plus
I not ಹೇಳ್ರಿ ನನಗ
49.73, sir. Amps.
ತಪ್ಪು.
So
How is it possible? Is it possible to draw, in terms of 40 amps, no load current? What is
Sir,
IM?
1.77.
See, no load current cannot be so much high. No, Chinna, how did you get this 40? IM ಎಷ್ಟು ಬಂದಿತ್ತು ನಿನಗೆ?
I am 49.73 ಬಂದಿತ್ತು, sir.
ಎಲ್ಲೈತಿ 49.7? ಇಲ್ಲಿ ನೋಡ್ರಿ, ಐ ನಾಟ್ ಕಂಡಿಡಿದ IM ಇಲ್ಲಿ ಕಂಡಿಡಿಲಿಲ್ಲ ನೀವು. 80 ನಾಟ್ ಎಷ್ಟು ಬಂತ?
1989.4.
1989.4. IM
divided
will
by
be 1.758, sir.
Square.
IM will be
Into
1.758 amperes.
800 na ಇದು TP.
Sir.
ಮತ್ತೆ ಎಷ್ಟು ಬಂತೈತಿ ಈಗ? 40 ಹೆಂಗ್ ಬರ್ತೈತಿ ಇದ್ರಾಗ?
1.758 amperes.
1.758. ಮತ್ತೆ ಇದು 40 ಹೆಂಗ್ ಬಂತಮ್ಮ ಚಿನ್ನ ನಿನಗೆ?
Correct ಇದೆ, sir. ನಾನು wrong ಮಾಡಿ.
Be careful, okay? So I naught, the no load current is 1.77 amperes. Okay, this is how you have to calculate. Okay, what is that you conclude from all these from these solutions? What is that you have understood? How to solve this problem? First, you need to, write down the formulas of what is to be calculated. Then go back, like how to IM, how IM can be calculated, how IC can be calculated, right? So this is how you can solve the problems. Okay, so I will you solve more number of problems. Okay, then we'll later on I will take up the other things. If you don't understand, if you don't get any problems, okay, then you please ask me. Okay, I will solve one or two more problems next. Okay, now, so we were after construction of your transformer, it has to be checked for its performance, isn't it? You have designed the transformer, that's fine. Now whether your design transformer meets the performance criteria or not, you have to check it now. So how do you check? The first criteria is a no load current. It has to draw as minimum no load current as possible. Okay, that is first operating characteristics. Other one is voltage regulation, another one is efficiency. Okay, so first one we have seen, that is no load current. And second one, to find out the voltage regulation, you must know what is the resistance and what is the reactance of the winding. Okay, so let us first find out what is the resistance. Okay, so let us calculate what is the resistance of a transformer. A transformer winding, you can say. Okay, not exactly the resistance of a winding. I mean resistance of a transformer. When I say resistance, it's the resistance of winding. Okay, let us start discussing about the resistance of a transformer. So let LMPT, okay, I will color black. Okay, let LMTP and LMTS. These are the length of the mean term of primary and secondary windings. You please take down what I am writing here. Let LMTP and LMTS be the length of mean term, length of mean term of primary and secondary windings respectively. Okay, next, RP and RS. These are the resistances of primary and secondary respectively. Resistance of primary and secondary windings respectively. Let it be in meters and let this be in ohms. Next, how do you find the resistance? You know, resistance is given by rho L by A, isn't it? So here I can write rho L is, we have taken LMTP into number of turns on the primary whole divided by AP. That is area of cross section of the primary winding. Similarly, on the same lines, you can find out what is RS. RS, that is secondary resistance of the secondary winding. RS is equal to rho L M TS into TS divided by AS. This is the resistances of primary winding and secondary winding. But I need to calculate what is the total resistance of the transformer. So you can calculate total resistance per phase. Total resistance per phase. Total resistance of transformer, total resistance of transformer referred to refer to primary. Okay. How do you write that? I think you remember. Total resistance R referred to total resistance is referred to primary winding is given by Rp plus Rs dash. If you recall, you R1 plus R2 dash, isn't it? Are you able to recall what I am telling you right now?
Yes, sir.
Resistance referred to the primary. So if I want to calculate the resistance referred to the primary, then the primary resistance plus second resistance referred to the primary, that is Rs dash or R2 dash. Okay, what is this Rs dash? If you remember, Rs dash is Rs divided by K square. What is this K square? K is what? Ts by Tpa. Are you able to understand what I'm saying? Are you able to recall what I'm writing here? This is the transformation ratio. This is the transformation ratio, isn't it? So you can substitute that here. Rp plus Rs into either you can write Tp by Ts, or you can write T1 by T2, or you can write P1 by P2 square. Okay, just a minute. Phone bar. Hello, ನಮಸ್ಕಾರ. ಈಗ ಕ್ಲಾಸ್ ನಡೆದತ್ರಿ, 4:20ಕ್ಕೆ ಮುಗಿಸಿ ಬರ್ತೇನೆ. Okay. You please, tell me whether you are able to follow what I am explaining. Hello.
Yes, sir.
Yes, sir.
Similarly, on the same lines, can you able to write the total resistance per phase of a transformer referred to secondary? Total resistance, that is per phase, of transformer referred to secondary winding. How do you write? Rs is equal to Rp dash plus Rs. Now Rp dash is equal to what? Rp into K square. Isn't it? You have to recall what you have studied earlier. So in the same way, you can write down Rp into bracket Ts by Tp square plus Rs. Okay, these are the resistances. Why I want all these things? Because if you know the resistance, then you can find out what are the losses. Right? If you know the losses, then you can find out what are the efficiency, isn't it? So if you know this, okay. Let me start. Just okay. So by default it is taking red. So the total losses, what are the losses? Total I square R losses in windings. What are the total losses? Total losses, total I square R losses in windings, that is copper loss, no? So you can write PC or PCU. So that is IP square RP plus IS square RS. So these are the total losses, isn't it? So once you find out this, so once you find out RP, okay, this RP and this RS. Okay, once you find RP and RS, okay, then the resistance at resistance of copper, resistance of copper at 60 degrees given. Not resistance, you can say resistivity. Okay, so resistivity of copper at 60 degrees, it's 2.1 into 10 raised to minus 6 ohm centimeter, or you can also write 2.1 into 10 raised to minus 8 ohm meter, or you can write 0.021 ohm per meter per millimeter square. This is how you can write resistivity. Okay. Now, mean length turn, that is of a primary winding. Let us take the first one. Mean length of turn of a primary winding, that is LMTP is equal to pi multiplied by mean diameter of the primary winding. Are you able to link what I'm explaining? See, I have started with we are finding out the operating characteristics out of which we are discussing about voltage regulation. So to know the low voltage regulation, we must know what is the resistance. Okay, so I am discussing about the resistance of the transformer windings, primary and secondary. So for that, I have defined that LMTP and LMTS, that is the mean length of the primary winding and secondary winding, and RP and RS are the resistances of primary and secondary winding, and the RP is equal to rho L by A. Okay, L is LMTP, which is to be multiplied with the number of turns of the primary. Similarly, we can find out what is RS. So the total resistance referred to the primary, it can be given by RP is equal to RP plus RS dash. And what is this RS dash? That is RS into 1 by K square. That's how we transform the resistance to the primary side. Similarly, if you want to transform the resistance to the secondary side, then you just add RP dash to the RS. Here RP dash is RP into K square. So we have done this. Then what is this LMTP? This is the mean length of the primary winding. LMTP is the mean length of the mean turn, or mean turn of the primary winding. Okay, so mean length of the primary winding is mean length of the turn of the primary winding is given by pi into mean diameter, pi into d. That is the mean length of the primary winding. Similarly, you can find out what is the mean length of the secondary winding. Okay. So the mean length of the primary winding LMTP is pi multiplied by length of the mean diameter of the primary winding. Now, number of primary turns per phase, you know that. Number of primary turns per phase. What is that? TP. TP is equal to VPPH. That is primary winding per phase divided by ET. That is voltage per turn. You can easily find out what is the number of turns per phase on the primary. Okay. Now, the resistance of the secondary winding, the resistance of secondary winding, that is RS. Let us take this per phase. Okay. Per phase, RS is given by rho LMTS into TS divided by AS. Okay. So LMTS is what? LMTS is pi into mean diameter of secondary winding. Similarly, what is number of turns on secondary? TS per phase, VS per phase divided by ET. Therefore, resistance of the transformer referred to the secondary just now I have given to you. Okay, this is about the resistance. So once you calculate, okay, once you calculate RP and RS, you can calculate what is the total losses, I square R losses. Once you know the losses, you will find out what is the efficiency. Okay. Now, in the next class, I will discuss about the reactance. Okay, reactance of the transformer. Okay, that we will discuss in the next class. If you have any doubts till now, please clarify your doubts. Any doubts? Okay.